Hello everyone, it's your boy the Canologist. We're going to be doing another Leetcode today. This is called First Bad Version. What's so bad about this version? I do not know, but we will find out. So first of all, you're a product manager leading a company. Alright, that's already false. I'm an engineer, not a product manager. Yeah, I'd see myself, I'd probably want to be a tech lead instead of project manager or product manager. Or I guess product manager could be tech lead, but I don't know. It seems more on the sales slash customer facing side versus like I want to just be like coding, you know. I prefer just to like be in my corner of the room and just like code, build in silence. Yeah. Some people are good at the product management stuff. Like I've seen some really good product managers in the field. It kind of goes with like whatever your personality type is, right? Like don't just go for something for pay, right? Like both roles could pay well, right? You could be a well-paid product manager, you could be a well-paid dev. It just depends on what your proclivity is. Let's look that up. What is proclivity? It's like what your tendency to do something is. So your tendency to choose or do something, right? So it's like if your proclivity is towards coding, right, then go the dev route. If your proclivity is towards like building a product, like product centric type of work where it's like, okay, I create the marketing for this, I look at the code for this, I look at everything to do with this product, then this is for you, you know. But for the purposes of this question, we are product managers. Currently in a team developing a new product. Unfortunately, this version of your product fails the quality check. Since the version is developed based on the previous version, all the versions after a bad version are also bad. Makes sense. Because if the previous version is good and it's built upon the previous version, we have to find the fuck up. Because everything from this point onwards is going to be fucked up because it's going to carry on the bullshit from that last version. So suppose you have n versions, 1, 2 to n, and you want to find out the first bad one. All you have to do, which causes all the bad ones to be bad. Okay, so you're getting a boolean, API boolean is bad version, returns whether the version is bad. Okay, cool. Implement a function to find the first bad version. You should minimize the number of calls to API. Okay. So n equals 5, the bad is 4. I feel like this is one of those midpoint questions where you just go to the middle, and if it's bad, you keep going to the left till you find the correct one. Because all the previous versions will be good. So there's no point in going to the end. So what I would do is like n, whatever n is the number of versions. 1 to n. Find out the first bad version. It doesn't say what n is. Is n an array? Is n an integer for number of versions? So now n looks to be an integer because your input n is just an integer. It's not an array. Right? So how do we find out whether something is bad? 1 to n. Is bad version. So this will check if that number is bad. Now I'm going to reduce the number of calls to the API. Okay. So right away, since I know everything after the bad version will be bad, I'm just going to cut it in half. So I'm just going to do this, mid, n divided by 2. Floor 2, just to be fair, right? So if it's 2.5, it's going to be 2. We chop off the integer. We just continue from 2. If n So if is bad version mid equals true, so basically I'm saying we cut this thing in half, right? So we should either have a bad or a good, right? If it's true, is bad version mid equals true, that means it's bad. Now we want to find the first one. So we're going to go for I in no while I because I don't want to change the value of mid, so I'm just going to make a copy, put it in I. So while I is not equal to so if it's true, so while is bad equals false, so if is bad version at I is not equal to false, I can delete this. So while it's true, and then while is bad version, so if it's bad, no, I have to keep this. So if it's bad, is bad equals true. What does it do? So is bad equals true. Is bad 3 equals false. So it's not bad. So if it is bad, so while it is bad, then while it is bad, while it's bad, I want to keep going left. So cut it in half. If it's bad, I want to keep going back. So I equals, so I minus equals 1. And then it's eventually going to reach a true state. And we can't go less than 1. So keep going, and then I'm going to say return I. So basically, if it is bad, so I cut it in half. If it's bad, I have to find the first bad. So I keep going back until I find the first bad version, right? Until it hits 1. So if it hits 1, just return 1. Otherwise, it's going to keep going back until it hits true. I equals 1 is true. If I equals 1 is true, oh no, until it equals false. So while I is bad is false, so false means it is a good version. Because it is bad, right? If it's a good version, it's false. So until it hits false, then I just return I. Or I'm just going to look at the next element so I never get to the point at which I get to a positive. So that way I can just return the element as is. Boom, just return I, otherwise keep doing it. So it's I minus equals 1. So that's basically I is equal to I minus 1. And then if it's good, so I'll go, if it's bad, keep going through this while loop, then return. If it's good, so if I cut in half and it's good, I have to keep going until it's bad. So if J equals mid, let me just extrapolate these to the top. So I just keep my logic here. So I equals mid. A equals B equals C. Assign single value to multiple variables in one line. So I'll do this. So this is some more syntax. So I equals J equals mid. And mid is n over 2. If it's a bad version, keep going backwards till we find the first one. If it's good, then we go while J So while is bad, at J, so basically if it's good, J plus equals 1, and then or I could just put is equal to false. Sorry guys, like this logic is a bit, it's like inverted, you know, so it's like it's all over the place. If is bad version J equals false, which means if it's a good version, is bad is false, that means it's true, it's a good version, then increment J plus 1, check it, true, return J. That's basically my logic. So if it's bad, keep going back. If it's good, keep going forward till it hits with the first bad, and then we return the value. So this should be a good enough answer. Let's try it. Boom. I don't know why I'm so happy. Come on. Come on. Don't time out. Please don't time out. Please don't time out. Please. Time limits. Why? Why? I literally cut the array in half at the beginning to reduce time complexity by n over 2. Then just increment. Why? Why? Why are you guys doing this to me? Why are you doing this to me? 11 out of 24 tasks is passed. N is 2 million something fucking... Oh my gosh. Why? Why? I mean, this could also be a case of binary search, where you just go n over 2 and you use logarithmic. If I do BST, this is actually binary search. This is actually binary search, because you have to keep dividing by 2 if it's positive or less than. So BST algorithm. So BST, binary search, pseudocode. I know it's like you get the midpoint, which is what I basically did, and then so you go left and right, and then while left is greater than right, mid equals left, right divided by 2. This is basically what I was trying to aim for when I did mine, because you still have to use left and right. Because if you go to mine, right, like I didn't implement binary search off the bat, but the logic I used is it uses a midpoint, right, and then I go from left, and I go from right if it's not that, and that's basically what this is. The only difference between mine and this is it keeps getting a new midpoint. So that reduces your time complexity by n/2, so it becomes a log of n time. It reduces exponentially. So mine was still O of n. That's the flaw in mine. So at least we know, right? Like at least we know. At least I'm not like brainlessly going at this. Okay, so let's implement it. So we have a target n. Well, left is 0, right is length of n minus 1. Okay. But it's inclusive, so I can go, it's going to be left is 1, and then right will be n. Because it's inclusive, and it doesn't include 0, because it's not 0 indexed. So this is going to be the difference. Right, this is going to be the difference. So I have my code here, you guys saw it, right? We gave it an honest try. It's passing the test because my logic does work. This does follow the original principle of binary search, right? Because it's going to a midpoint and then traversing, and it's going to a midpoint and then traversing the other way if it doesn't meet the condition, right? So now we want to do this with an improved time complexity. All we're doing here is improving the time complexity of this solution, right? Because it's taking too long when you get an input that's in the millions, in the billions, right? So let's do that. So first, let's define our left and right point. So left equals 1, right equals n. Let's control X this. I can delete this. Let's delete this. While so we want to continually find the midpoint where this thing is not correct. And this is to reduce the number of calls. So first we get the midpoint at every iteration. Boom, mid equals left plus right floor 2. Right, so we do that. Then I want to say if list.mid equals target, right? If list.mid equals target. So that's binary search. In this case, we don't want to do it. We want to slightly modify the logic of binary search to find what the first bad element is. So they don't tell us the output value, do they? Input n bad equals 4. This is knowing it's 4. I want to find where the first bad one is, so n divided by 2 if okay, here's how I decide. I find the first bad by saying if n minus 1 is good and n plus 1 is bad. That's my middle point. So this list.target, if mid list equals target, what I'm going to do is take my midpoint. If mid equals So if is bad version mid minus 1, which is to the left of the midpoint, because if I have the first bad version, the one to the left should be good. So this should be false. And is bad version mid plus 1 equals true. So to the right, if this is a bad version, that means I have the first bad version. Then I just return mid. Done. Like here, return mid. L if it's less than target or greater than target. So if list.mid equals bad, else if it's good, go to the right. So L if the list mid dot left is less than the target, so if it is good, I want to go midpoint plus 1, because then we start. So if is bad version mid equals false. I have to increase it. So good is the furthest to the left. We want to find the first bad. So if we find the first, if the midpoint is good still, we just start the new midpoint at plus 1 and ignore everything to the left. Then figure out how to slide this guy. So mid equals, so left equals mid plus 1. Left mid plus 1. If else, so right, that means else right equals mid minus 1. Right? So if it's still false, no, if it's still true, because right now if mid is false, then you have to bring the midpoint plus 1, because we have to eliminate all the goods. Now we want to find where the first bad is, right? The next one could still be good, right? So we just want to find the midpoint. If the midpoint is good, we go to the next one. Boom. This is the new midpoint. Now we find where the first bad one is, right till the end. If we have all falses, we want to find where the first one is. So we have to go till we get good. So we go mid minus 1, because that's still false. So it's the opposite. So I'm basically modifying binary search for the purpose of this question. And then it will return based on this. It'll return the mid based on these two conditions. So one's looking at the mid minus 1. Mid minus 1's false, satisfied. Mid plus 1's true, satisfied. All right, so let's try it. Seriously? Why? 3 and 4. Okay, something's off by 1. Right is n. Left is n. Oh, it's floor 2. Do I go mid plus 1? Is that why? So if mid is bad version is mid minus 1. So this bad version equals false. False means it's a good version. And the midpoint plus 1 equals true, return mid. Left, right, mid equals false. It's off by 1. Okay, I'm curious. What's this? Is this also off by 1? Null and 1. What about this? If n equals 1, return 1. I'm just curious about the second condition. Does that pass it? Yes. Okay, so if n equals 1, return 1. We don't have to go through all this. That's a quick fix. And then if what if I control X this to prevent it from doing this, and then if I go here, actually no, let's just keep it simple. Keep the logic here. Just return as is, right? The other thing is, if it's greater than 1, I want to go into this function. So then left equals 1, because 1 is the first version. N. So if I go n plus 1, does that fix it? I'm just curious. No. If I go n minus 1, does that fix it? No. Okay, so it's not something to do with these parameters here, because this actually models the versions correctly. Left and right, start and finish. So left or right divided by 2. What if it's mid plus 1? I'm curious. You know why? It's because it's floored and you get rid of the integer. Let's try it. I just want to confirm my suspicions. Wrong answer. 13 out of 24 test cases. Output is 2, expected 1. Okay, so there's that. There's the floor, and then there's 1. What's the time? Let's correct it on here. Okay, we're at 34 minutes. Let's just correct it. I just want to see where I'm going wrong, but my logic for the most part is generally correct. I just have to modify BS binary search for the question, which is what I pretty much did. It's just off by 1. So let's see what, I'm probably making some really silly mistakes, so let's just use ChatGPT. Boom. My code. Fix my solution. You need to adjust your logic in the binary search to correctly identify the bad version. Use the corrected thing. So mid. So I first do this, left, right. Okay, cool, that's good. Left is less than right. What did I do here? Left is less than right. Okay, that's good. Mid equals divided by 2. Right. If is bad version is true, mid could be the first bad version. So include it. Ah, okay. So they just removed the actual. What I did was I tried to create logic to find the 1 point. They're just eliminating this completely and just including bad versions. So if bad version, if it's a bad version, right equals mid, just return it. Right is now the midpoint because it's still going to be bad, and then left is mid plus 1. So it's still the same logic, they just swapped it around, and they got rid of my logic for finding left and right. So basically I was using the before and after to figure out whether it was valid or not. But the reason why that doesn't work is if you have an array with 2 elements, it'll look at a null, right? So you could have cases where it doesn't work. Then just return left. Left equals mid plus 1. So we keep going left. Left will always be inching towards a bad. So it's basically still binary search, it just modifies. Beat 7.03%, yeah, so basically all it does is looks at the midpoint like we did before, right? Like I also did my original iterative solution with O(n) time. It's just that this solution, because it uses midpoints, it halves it every cycle. So let's say you have 1,000, right? Now your search goes down to 500, now it goes down to 250, now it goes down to like 125. Right, do you see that? It's like exponentially decreasing the amount of times you have to call is bad version. You see, throughout this whole thing, we're only calling is bad version here. Notice that? That's only like 3 calls to, like, let's say we're at 1,000, it's only 3 calls. Let's say we're at 1,000,000, it's only like 6 calls, right? Whereas if I do an iterative solution, it's going to do it like thousands of times, right? So that's why this is the optimal solution. It's a binary search solution modified for the purposes of this question. All right, so if you liked that video, please give it a thumbs up, subscribe, and comment below. Thank you.